On account of its strong highlights, this would provide us with a much fuller picture of the world as far as we might be concerned now. The most awesome picture ever seen was simply taken by the James Webb Telescope. Accompany us as we get more familiar with the James Webb Telescope and how it could make everything different. How everything began. After the telescope was first recommended in 1996, 3 groups of researchers and engineers from both the public and private sectors got together to check if NASA could actually build the telescope. All 3 groups reached the same conclusion. The telescope could be built. In 1997, NASA agreed to pay for additional studies to improve the technical and financial needs. By 2002, the organization had picked teams to build the telescope's most important equipment and an advisory group of scientists to assist with the building process. The telescope was formally named the James Webb Space Telescope that same year, to honor the former head of NASA who made significant contributions to the development of the Apollo program. When engineers and scientists began building the Webb telescope in 2004, they needed to come up with new advancements and techniques to meet the mission's severe scientific needs. While astronauts could fix and improve Hubble from Earth, Webb would have to do all its work from too far away for Earth to help. Regardless of these issues, the team finished all 18 mirror pieces and put them through numerous tests to ensure they met the standards. It was finally possible to envision the telescope going into space and doing its job. The James Webb Space Telescope was built from 2012 to 2013. Different parts of the telescope were being built in various places around the world. Construction began on Webb's sunshield layers in 2013. These layers protect the telescope from too much heat and let it function well in space. Over the next few years, Webb's unique science instruments were put through extreme tests with high temperatures and vibrations. Simultaneously, the telescope's 18 separate mirrors were carefully placed on its backplane frame. These parts were assembled and tested at NASA's Johnson Space Center in Houston, Texas. In 2017, the telescope and its equipment also went through one final round of environmental tests in a large thermal vacuum chamber to ensure they would work properly when put into space. Webb was finally launched into space around the Earth on December 25, 2021, at 7:20 a.m. Eastern Standard Time. How it functions. So how does the telescope truly work? People often make space travel sound too simple, so when you first hear about it, it might seem like just another camera. But that's not the case. It's entirely different, which is why it took so long to go from concept to launch day. The James Webb Telescope is a powerful telescope made to look at things in space that are too cool or faint for traditional telescopes to see. These are things like stars, galaxies, and planets that are just beginning to form. The telescope is designed to capture infrared light, which these distant celestial bodies use to radiate most of their heat. This allows us to learn more about these things. Infrared light can't pass through gas and dust, which makes it look hazy to our eyes. Webb, on the other hand, can see bright radiation as well as visible light and infrared radiation. This allows it to take pictures of things that are obscured by dust and gas, giving us a better view of things happening far away in the universe. It is also possible to study the properties of things on Earth, like their chemical composition and temperature, using infrared light. Infrared light is useful in many areas of physics, science, and technology. It can help us look into how stars, galaxies, and other cosmic objects are formed and how they change over time. It can also be used to find signs of chemical pollution in our environment. The telescope has a large array of mirrors, advanced imaging and spectroscopy instruments, and cutting-edge thermal control systems that let it work in harsh conditions like space, which you already know is very harsh. Because this camera is designed to go into space by itself, it had to be built so it could handle anything out there on its own. After the telescope was launched into space and separated from its launch vehicle, it unfolded and began its long journey to its destination, going through a complex set of steps as it went. There were several significant stages in this process, such as crossing the moon and breaking into different pieces. The telescope became one of the most powerful tools of its kind as soon as it was fully set up. How it got to space. Let's take a look at the steps this groundbreaking telescope took to get into space before we discuss why it was so important. The launch was the first thing that had to be done. The solar array was set up after the launch. 2 different pallets were deployed on the 3rd day of the journey while the astronauts were still inside the ship. The important sun shields for Webb were stored on these pallets. These shields keep the telescope cool and allow it to work properly in space. The deployment of these shields was crucial for ensuring that the camera could function well during its journey. On the fourth day, the tower that held the instrument package was moved to its final position and assembled. There were many complicated steps in this process, but everything went smoothly due to how the telescope is constructed. The speedfold was then raised. The sun's pressure works on the large sun shield, creating a force that keeps the telescope stable. Next was the release of the sunshield membrane cover, which revealed the tennis court-sized sunshields. After everything was set up, the sunshield and mid-booms were deployed. The 5 segments of the sunshield were then pulled apart. But this isn't the end. When the James Webb Telescope was put into space, it had to go through several important steps. The secondary mirror and a frame to hold the smaller mirror in place were installed on day 10. The primary mirror wings were then extended on day 13, giving the telescope its standard shape. After these steps were completed, the telescope was ready to begin its job of observing stars and planets far away. What is the real point? What's interesting about the James Webb Telescope is that it wasn't designed to do just one thing. A considerable number of tasks are expected of it. Let's delve into this a bit more. Traveling back in time, scientists like Daniel Einstein, an astronomer at the Harvard-Smithsonian Center for Astrophysics, can use telescopes like the James Webb Space Telescope to travel back in time and see galaxies when they were just beginning to form. Light travels slowly, so a planet that is far away looks older than it actually is. The telescope can observe the early history of galaxies to learn about how they formed and changed over time. Since it can see galaxies so far away, scientists like Einstein can get a complete picture of how galaxies form and evolve over time. Webb is excellent for studying distant galaxies because it can see infrared light. The universe is expanding, which makes the light from these galaxies longer over time. This shifts the color of light from visible or ultraviolet to infrared. Webb is very good at detecting infrared signals because it is large and cold. This allows it to see much farther into space than other telescopes. This makes it possible to observe galaxies as they grow and change, capturing images of how they evolve over time. By studying these changes, we can learn more about how galaxies form and develop. In summary, gathering what we know, scientists study stars from the specific point where they were born. Stars are born from dense clouds of gas and dust known as stellar nurseries. Since these clouds are so dense, visible light can't pass through them, making it difficult for scientists to use standard optics to study these regions. However, infrared light can penetrate the dusty clouds more easily than visible light, allowing scientists to see into the heart of these star nurseries in a way that other scientists can't. Because the Webb telescope can see infrared light, scientists will be able to study these regions in much more detail than they could before. Maria, an infrared astronomer at the University of Arizona, is the principal investigator of one of Webb's cameras. She explains that red light has a longer wavelength and can pass through the dust in our atmosphere better than blue light. Besides that, infrared light can penetrate deeper into dusty galaxies than visible light. Because of this effect, the sun looks redder at sunset than during the day. At the same time, because it can see infrared better, Hubble has only been able to study the formation of stars on a surface level. The broader range of infrared bands on Webb, on the other hand, will allow scientists to see deeper into the dust and learn more about how stars are born and evolve. It's difficult to see black holes because they can trap light, making them some of the strangest things in the universe. However, we can observe how black holes affect the stars and galaxies around them. Scientists have been able to study various aspects of black holes using telescopes like X-ray telescopes. For example, they have studied how the violent destruction of nearby stars heats the region around black holes. With the launch of NASA's Webb Telescope, its infrared instruments will allow scientists to learn more about black holes. They can learn more about black holes and the complex physics that occur near them by observing the cooler gases and stars that swirl around them. Scientists are still studying black holes even though they seem invisible. They will continue to be an important area of study in the future as well. When you look at stars in dense, dusty regions of space, studying them can be challenging, which is why we need telescopes like Webb. These obstacles can't be addressed by optical telescopes like the Hubble Space Telescope. The cool thing about Webb is that it can capture the light emitted by the stars themselves, even through dust clouds. This means that scientists can use the telescope to observe parts of space that they can't see right now. The James Webb Space Telescope can detect and study the